All right, ready to build some serious knowledge. Today we're diving deep into the world of civil engineering. We're talking bridges, buildings, roads, the very infrastructure that makes up our world. And you've given us quite a stack of sources on this, so we're ready to unearth some seriously fascinating stuff.
Yeah, it's one of those fields that's often overlooked, but it's amazing how much it impacts our everyday lives.
Absolutely. It's like the backbone of our modern world, wouldn't you say? And it's way more than just, pouring concrete. We've got why learn civil engineering, a whole history of civil engineering, and we're even taking a peek into the future with the future of civil engineering.
And you'd be surprised how much the history and the future are actually intertwined. Today's innovations, they often stem from the ingenuity of those early engineers.
Oh, absolutely. Speaking of the past, let's start there. When we say civil engineering, what are we even talking about?
At its core, it's about designing,
Hmm.
constructing, maintaining all the infrastructure that makes our modern world possible.
So it's not just buildings.
No, it goes way beyond that. We're talking roads, bridges, tunnels, dams, water treatment plants. It's anything that serves the public, really.
Wow. Okay. So it's a massive field then.
Yeah.
And looking through these sources, I see all sorts of different areas within civil engineering. Structural, geotechnical, transportation, environmental. There's a lot to unpack here.
Absolutely. And each of those areas has its own unique challenges and focuses.
Right, like a giant puzzle.
Yeah.
But you're building the pieces and the picture at the same time. And speaking of building, I have to admit, I came across some pretty intimidating formulas in these sources. Load, stress, strain, bearing capacity. It's a bit like physics class all over again.
Right, but those are the core concepts that civil engineers work with every day. Think of it this way. Imagine a bridge, right?
Okay, got a bridge in my mind.
That bridge has to support the weight of cars, trucks, sometimes even trains.
Yeah, and if it's not strong enough, that could be,
Exactly. And that's where those concepts come in. Load refers to any force on the bridge, like the weight of all those vehicles. Stress is how that force is spread through the bridge's structure. And strain is how much the material bends or stretches under that weight.
so civil engineers use all that to make sure a bridge can actually handle the load without, collapsing.
Yeah, it's all about safety and making sure things are built to last.
That makes so much more sense with an actual bridge as an example. I knew bridges had to be strong, but I never really considered all the calculations behind that strength.
And that principle, it applies to everything. Skyscrapers, tunnels, even underground parking garages.
Wow, that's amazing. Speaking of amazing, this history of civil engineering source is blowing my mind. The things those early engineers accomplished, it's incredible. Like the Egyptian pyramids, built thousands of years ago. How did they even...
Right, the pyramids, the Roman aqueducts, Gothic cathedrals, these are marvels of engineering. And
Yeah.
they were pushing boundaries with limited tools and materials compared to what we have now.
It really makes you appreciate their ingenuity.
Yeah.
They were working with hand tools, basic materials, and yet they created structures that have stood for centuries.
They were masters of observation, understanding how materials worked, and using that knowledge to overcome limitations. Like the Roman engineers who built the aqueducts. Their understanding of hydraulics was incredible. They were moving water over huge distances using gravity alone. We still study their designs today.
Wow, they really were laying the foundation, literally, for everything that came after them. It's just incredible to think about. And that foundation has led to some seriously cool innovations. This future of civil engineering source is like straight out of a sci-fi movie. Self-healing concrete, robot construction workers. It's wild.
It really is an exciting time for this field, and it's not just about the cool tech, although there's plenty of that. It's about facing the challenges like climate change, and finding solutions.
Right, building a sustainable future. Speaking of which, sustainable building practices, that's not just a trendy term anymore, is it?
Not at all. It's a necessity. The construction industry uses a lot of resources, a lot of energy, so minimizing the environmental impact, that's crucial.
Absolutely. And there are some incredible advances happening, like that example from the sources, the Bullet Center. Talk about a sustainability superhero. Solar panels, rainwater harvesting, even composting toilets.
The Bullet Center is a perfect example of what's possible with sustainable design. It's net zero energy, produces as much energy as it uses, and get this, their rainwater harvesting saves thousands of gallons of water every year.
That's amazing. Like filling an Olympic swimming pool every year with just rainwater, that's wild. And on the topic of cities of the future, we got to talk about smart cities. I'll be honest, that term always seemed a bit vague to me. What does it actually mean for a city to be smart?
Imagine a city that uses technology and data, but to actually make life better for people. Sensors everywhere, monitoring everything from traffic flow to air quality, and then using that data to make things run smoother.
So we're talking traffic lights that change based on real-time conditions, buildings that adjust their energy use, maybe even self-driving public transportation, right?
Exactly. And this isn't some distant future either. Barcelona, for example, they've already got a lot of smart city initiatives up and running. And they've seen some great results, less traffic, less water usage, even improved safety.
Wow, so smart cities aren't just a cool concept, they're already making a real difference. That's incredible. But you know me, I always got to ask, how does that even work? And nothing screams that louder than self-healing concrete. It's like something out of a comic book.
Right. But it's based on a surprisingly simple idea. Researchers figured out how to put bacteria into the concrete mix. When a crack forms, water gets in and it activates these bacteria.
And then the bacteria, they get to work, like little concrete surgeons patching things up.
Exactly. They use the water and calcium ions in the concrete to produce limestone. And limestone, well, that's a key ingredient in concrete itself.
So the bacteria are basically healing their own cracks. That's brilliant. And speaking of cool building materials, it's not all about concrete anymore, is it? I was reading about graphene, recycled plastics. It sounds like the materials of the future are already here.
They are, and they offer some amazing advantages. These materials, they can be lighter, stronger, more durable, and often they can be made from recycled products, so better for the environment too.
Okay, so stronger, greener buildings. I like it. But hold on, we can't forget about the robots. I'm picturing a construction site. But instead of workers, it's drones flying around, 3D printers making building parts, robots doing all the heavy lifting.
You're not far off. That kind of automation is already starting to happen. Take the MX 3D bridge, for example, the world's first 3D printed steel bridge, designed and built entirely by robots.
Wait, seriously, a whole bridge 3D printed out of steel? That's incredible. But robots on a construction site, that's got to be about more than just looking cool, right?
Of course. Safety is a huge factor. Robots can take on dangerous jobs. But it's also efficiency. Robots work faster, longer, more accurately than humans, so you get things built quicker with less waste.
So more efficient, more precise, and safer. Sounds like a win-win-win to me. But hold on a second. All this incredible technology, amazing materials, what happens when a hurricane hits? An earthquake? We got to think about resilience, too.
Absolutely. That's a critical point. It's not just about building impressive structures. It's about making sure they last. Building for a world of more extreme weather, rising sea levels, all of that.
Right, so we're talking about designing for storms, floods, even earthquakes.
Exactly. And that's where resilient infrastructure comes in. Buildings that can withstand those forces, recover quickly. We're talking structures that can move with seismic waves, flood barriers that adapt.
It's like we're trying to outsmart Mother Nature herself with engineering.
Well, in a way, yes. But it's more about working with nature, understanding how these forces work, and designing structures that can handle them. And that brings us to another important aspect of the future: data.
Oh, right, because we can have all the smart cities and robots in the world, but without the data to guide them, it's just a fancy light show.
Precisely. Data is becoming just as important as concrete and steel these days. Take building information modeling, BIM for short. It's like creating a digital twin of a structure. It lets engineers see how a building will behave before they even break ground.
So like a super detailed simulation.
Mm-hmm.
That's incredible. And it's not just for design, is it? We can use data to monitor buildings in real time, maybe even predict problems before they happen.
Exactly. Sensors in bridges, buildings, roads can pick up on potential issues, stress, strain, vibrations, all sorts of things. And now we're using AI to analyze that data. It can spot patterns, predict problems, sometimes even before a human inspector would notice anything.
It's like giving these structures a sixth sense.
In a way, yes. And that ability to anticipate and prevent failures, that's going to be crucial in the future, not just reacting to disasters, but preventing them.
So we're not just reacting after something breaks, we're preventing the break from ever happening.
Exactly, being proactive instead of reactive.
Okay, that makes a lot of sense.
Mm.
So what I'm hearing is the future of civil engineering, it's not just about building bigger and better. It's about building smarter, greener, more resilient structures. We're talking cutting-edge tech, incredible materials, tons of data, all working together to build a world that's, both amazing to look at and built to last.
Couldn't have said it better myself. And honestly, I think we're just scratching the surface of what's possible. Who knows what incredible innovations are coming next?
It really makes you wonder, what will we build with all these tools? Well, that's something to think about. To our listener out there, thanks for joining us on this deep dive into civil engineering. We've gone from the ancient pyramids to smart cities, self-healing concrete. It's been a journey. And hopefully you've learned something new about the incredible structures and systems all around us.
It's a field that's always pushing boundaries, finding new solutions.
Absolutely. And as we've seen, it's more important than ever as we face the challenges of a changing world. Well said. Thanks for being here to show your expertise with us.
Happy to be here.
And to everyone listening, thanks for joining us on the deep dive. Until next time, stay curious.